Bismillahirrahmanirrahim. We have already studied about the analytical derivation for normal and shear stress, and then we have studied about the maximum and minimum stresses, normal and shearing stresses. We have studied about principal plane, principal stresses, and maximum in plane shearing stresses and maximum shearing plane. Now, using all those analytical formulas, we will solve a few examples of the book from reference book. Let's start with the problem number 923, which states at a certain point in a stress body, the principal stresses are sigma x is equal to minus 80 megapascal and sigma y is equal to minus 40 megapascal. Determine the sigma and tau on the planes whose normals are at plus 30 degree and plus 120 degree with the x-axis. Show your result on a differential element. We have been given with the principal stresses, so there means there will be no shear stress. We have given sigma x is equal to 80 megapascal, sigma y is equal to 40 megapascal. That was minus, therefore it is a compressive. You need to determine the value of normal stress and shear stress at a plane whose normal makes an angle with the x-axis as 30 degree and 120 degree. And finally you need to sketch the differential element. From the problem, as we know that tau xy is equal to tau yx equal to 0. Now sigma will be equal to what? Normal stress is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta minus tau xy sin 2 theta. Now we need to determine the normal stress at 30 degree. So putting the angle theta is equal to 30 degree in this formula and putting the value of tau xy is equal to 0 in this formula, you will get what? Sigma x is 80, sigma y is minus 40, therefore 80 minus 40 divided by 2. Sigma x is 80 minus into sigma y is what? Minus 40 divided by 2. What will be the value of cos 2 theta? 30. When you put 30, it will become 60, so cos 60 degree. Minus tau xy is what? 0. 0 multiplied by this will be 0. So sigma normal at 30 degree will be equal to 50 megapascal. Now similarly, you can find out the value at 120 degree. You can put the value of theta as 120 degree. In this formula, you will get the value of sigma 120 or sigma n dash. There is another process as well. You can write that sigma 30 plus sigma 120 will be equal to sigma x plus sigma y, and you can easily find out the value of sigma 120, which is equal to what? This. आप इस फॉर्मूला से भी कर सकते हैं कि नॉर्मल प्लस जो परपेंडिकुलर प्लेन है उन दोनों का सम विल बी इक्वल टू कांस्टेंट. तो आप सिग्मा एन आपने फाइंड कर लिया, विच इज एक्चुअली सिग्मा 30. तो सिग्मा 120 आप यहाँ से फाइंड आउट कर सकते हैं, विच कम्स आउट टू बी minus 10 megapascal. After that, you need to determine the value of shear stress at 30 degree and 120 degree. What is the formula of shear stress? That is equal to what? Sigma x minus sigma y divided by 2 sin 2 theta plus tau xy cos 2 theta. This term will become 0. Put the value of sigma x, which is 80, value of sigma y, which is minus 40, sin 2 theta means sin 60 degree. So we have the value as 52 megapascal. As we know that shear stress on the perpendicular plane will be equal in magnitude but opposite in direction. So the value of shear stress at 30 degree will be plus 52 megapascal and shear stress value at 120 degree is minus 52 megapascal. Now we will draw the differential element. As we know initially that this element was like this. If we rotate this element with an angle 30 degree, which is a counterclockwise, means if you rotate this element this way, then you can find the value of sigma 30 and tau 30. Now I've rotated this element at 30 degree. Now it will become like this. What is the normal stress? Sigma m, which is sigma 30, 50 megapascal. I have drawn this 50 megapascal, 50 megapascal. And what was the value at plane which is perpendicular to this at 90 degree to this? That sigma 120 was 10 megapascal, 10 megapascal with a compressive. What was the value of shear stress at 30 degree? At 30 degree shear stress was plus 52. So you will draw a clockwise shearing stress value on this plane, this face, tau xy, which is 52 megapascal. And on the other side, this will become opposite to this. So in order to make this, you need to join the arrows at this point. You will get the direction. If this is a clockwise, this will produce an anti-clockwise. So let's come to the problem number 924. Problem number 924 states that A state of stress is specified in the figure. Determine the normal and shearing stresses on a principal plane. Number 2, on the plane of maximum in-plane shearing stresses. And number 3, the planes whose normals are at plus 36.8 degree and plus 126.8 degree with x-axis shows that results of all these on complete differential element or sketch the differential element. We have this specified state of stress means sigma x is equal to this, sigma y is equal to this, tau xy is opposite means in counterclockwise direction, so there will be tau xy will be minus. So we have sigma x equal to 32 minus sigma y is equal to minus 10, tau xy minus 20, tau yx 20. You need to determine what first. You need to determine the normal and shearing stresses on principal plane. And next you need to find out the planes of maximum in-plane shearing stresses. And after that you need to find the normal and shearing stresses at an angle 36.8 and 26.8. So starting with the principal planes. So what are the principal stresses? Sigma 1, sigma 2 that are equal to sigma x plus sigma y divided by 2 plus minus r. So sigma 1 is equal to 11 plus 29. After putting the values of sigma x, sigma y and tau xy, we got this answer 11 plus 29 which is 40 megapascal. Sigma 2 is 11 minus 29 which is 18 minus 18 megapascal. And what is the value of maximum shear stress tau max? That is plus minus r, it is plus minus 29 megapascal. Now we need to determine the principal plane also, which is equal to tangent 2 theta b is equal to minus 2 tau xy divided by sigma x minus sigma y. Minus 2 into tau x value is minus 20, sigma x is 32, sigma y is minus 10. So your answer comes out to be theta p is equal to 21.8 degree. This shows that a counterclockwise angle of 21.8 and plane of maximum in-plane shearing stresses will be what? At 45 degree to the principal plane. So we add 45 to this and we get the maximum shearing plane as 66.8 degree. As we know that there will be no normal stress on principal plane, therefore the normal stress on principal plane will be equal to 0, whereas the normal stress on maximum shearing plane is equal to average stress. Sigma n is equal to sigma x plus sigma y divided by 2, which is 11 megapascal. Now we will draw the differential sketch of differential element. What was the principal plane angle? 21.18 degree. So if we rotate the element at an counterclockwise at 21.8 degree, we get the maximum stresses sigma 1 and sigma 2. If we rotate this, what is the value of sigma 1? 40 megapascal tensile. And what was the value of sigma 2? Minus 18 megapascal. So we draw this. And there will be no shear stress on principal plane. Now your maximum shearing plane will be at what? At 45 degree to this. So it is at counterclockwise 66.8 degree. And at 66.8 degree, if we draw the element, we know that the normal stress is equal to the average stress, which we have found it out, 11 megapascal, and it is a tensile, so we have drawn tensile on normal stress. And what was the value of shear stress? The value of shear stress was plus 29 megapascal and minus 29 megapascal. So at this plane, what was the value of shear? Plus, so we will draw a clockwise rotation for this, which is plus 29. And at perpendicular to this plane we have minus 29. We will draw anti-clockwise rotation, means direction this way, this way. For positive it will be this and this. Now the third one, you need to determine the value of stress at this angle and shear stress at this angle. For 36.8 degree, what you need to put the value of theta as 36.8 degree, you get the answer. And if you put the value of theta as 126.8 degree, you will get the value of sigma at 126.8 degree, or else you can find the, using this technique, sigma will be equal to sigma x plus sigma y minus sigma 36.8 degree. Similarly, shear stress, put the value of angle in shear stress formula, which is sigma x plus sigma y minus sigma y divided by 2 sin theta plus tau xy cos 2 theta. Putting the value of theta as 36.8 degree, you will get the answer. And you know that once you get the value of shear stress at 36.8 degree, the value of shear stress at 126.8 degree will be of same magnitude but with a negative sign. So we have drawn this reference and differential element also at 36.8 degree. What is the value of normal stress? 36.1 tensile. What is the value of normal stress at 126.8, it is 14.1 megapascal compressive. Similarly, shear stress plus 14.5 minus 1. Then we have a problem number 925. So what does problem number 925 states? It says that there are two wooden joists of cross section 50 mm by 100 mm are glued together along the joint AB. They have been glued together at this joint AB shown in figure. Determine the normal stress and shearing stress in the glue if the P is 200 kN. You need to determine the normal and shearing stress in this glue. So how we will proceed for this numerical? Let's P is equal to 200 kN. Size of wooden joist is 50 mm by 100 mm. What is theta unknown, tau unknown. Value of theta is 40 degree. As we know that sigma x is equal to, so we draw this on a differential sketch element. Let's suppose a stress sigma x has been acting on it. For example, this normal stress. This is an inclined plane. This makes an angle 40 degree. So using the reference for a triangle, if this is 40, this is 90, this will be 50 degree. So your horizontal axis will be like this. This is your normal plane to this inclined plane. So if you draw this horizontal axis, this total angle is what? 90 degree. So this 40 and this 40 will be same, and what will be the remaining? This 50 degree. Sigma x will be equal to what? P divided by A. We know that P is equal to 200 kilonewton, A is 0.05 into 0.1, so we get this 40,000 kilonewton per meter square, which is exactly 40 megapascal. And there is no sigma y, no normal stress acting in the y direction or y phase. So what is the value of maximum normal stress in this glue? This will be equal to a sigma n at 50 degree. Actually what n makes an angle of 50 degree with the horizontal axis. So putting the value of 50 degree, sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta minus this. As we know that there is no shear stress on it as the plane is perpendicular. What is the value of sigma 50? That is 16.527 megapascal. And what is the value of shear stress at 50 degree? That is equal to sigma x minus sigma y divided by 2 into sine theta. So you get 19.69 megapascal. So we have a normal stress and then a shear stress. A normal stress is 16.527 megapascal and a shear stress of minus 19.69 megapascal. Similarly, you can solve the problem number 926. State of stress has been given to you. You need to find the principal stress is sigma 1, sigma 2. You need to find the maximum in-plane shearing stresses. You need to find the stress at 30 degree and shear stress at 30 degree. You have been given the value of sigma x, sigma y, tau x, y. All you need to do is use those formulas, put those values. You will get sigma 1 is equal to this, sigma 2 is equal to this, tau max this. Now you can find the value of this. You can find tangent 2 theta and draw this one. That's all for your today's lecture. Many examples will be studied in next lecture. Thank you for this lecture.